Today's lesson comes from Chapter 5, Lesson 1, and our goal is to write ratios to compare real-world quantities. Take a minute to watch the Nana's Chocolate Milk video. In it, you'll see a great example of how ratios are used so often in everyday life. In fact, you've used them all the time without ever realizing what it is you are doing. After you've watched the video, turn this video back on so that you can see what we're going to do with this or how it is related to ratios. So, after seeing the video, we know that Nana likes her chocolate milk made with just the right amount of chocolatiness. So it's important to note how she should accomplish it and then what the guy in the video actually did when he was making it for her. So on the first line where it says, how does she accomplish this, you should write the number of cups of milk that she should use when making her hot chocolate. On the second line, the one that comes after the word to, you should write the number of scoops of chocolate that she should have used. Note, in each half of the video, there was a different number of scoops used. Well, we want the one that she should use. If you put those numbers on correctly, you should have 1 on the first line and 4 on the second line, so that you would read the ratio as 1 to 4. That's right, you've just created a ratio. A ratio looks at comparing two different numbers. Here it would be 1 cup of milk to 4 scoops of chocolate. And if we use that ratio, we could find out how many scoops of chocolate we needed depending on the number of cups of milk that we used. Take a minute to write down why the guy in the video thinks that Nana's going to be mad at him. What did he do that was different from the ratio that we just described above that should be used to make the chocolate milk? So as mentioned in relation to the Nana's Chocolate Milk example, a ratio is simply a comparison of two numbers. A couple important points to note about them are that they must be written in lowest terms, and they must include no units. It's only going to be numbers here. This may not seem important now, but as we move on to the subsequent lessons, this will become more important. So we're just going to have numbers when we're talking about a ratio. There are 3 ways to write a ratio. The first one is the way that you wrote it above, and it looks like 2 numbers, 1 cup of milk, 4 scoops of chocolate with the word to between them. That word to is going to be important because when we read a ratio, we're always going to read it using the word to. The second method is going to be to put a colon between the numbers. Again, we still read that as the ratio 1 to 4. The third method is going to be to write it as a fraction. Now my suggestion, because you do have a choice in most cases, unless it asks you to write in all 3 of the ways, you can write it in any of those 3 ways you want. My suggestion is to write it in fraction form. The reason is because we have to write our answer in lowest terms, we're used to doing that when we write things in a fraction form. So for example, if we had the ratio, let's say 3 to 21, if we wrote it in that colon way, we might write that down and say, wow, I did a good job. I was able to correctly choose the right numbers. If I see that same ratio in fraction form, 3 to 21, it's liable to jog my memory that I can divide both the numerator and the denominator by 3, making my final answer 1 to 7. Notice, even in fraction form, we still read the ratio as whatever the number of the numerator is to the number that the denominator is. But sometimes helpful if we look at ratios in fraction form to remember that we have to write in lowest terms. Really important when we're looking at ratios to make note of the order that the problem tells us to look in. Notice we're always looking for the word to when we're doing a ratio. And this example says, what is the ratio of green fish to orange fish? What's important is that the green fish came first and the orange fish came second. We want to put our answer in the same format. So when we're looking at identifying the ratio of green fish to orange fish, I'm going to first count my green fish, and I'm going to note that I have 2 of them. So the first number in my ratio is going to be the number 2. Then I'm going to have the word to, Then I'm going to look at the number of orange fish. Well, here I have 1, 2, 3, 4, 5. So my ratio is going to be 2 to 5. Or I could use the colon. I would still read it as 2 to 5. Or I could use the fraction, and I would still read it as 2 to 5. If you're feeling confident with how to write ratios, go ahead and solve the next picture with the red and the black fish. If not, listen up as I go through this problem with you. Here it again says, what is the ratio of blackfish to redfish? I start by identifying the word to. In front of the word to is the word blackfish, so that's what I should look at first. Then second, I should look at the number of redfish I have. So on the tank on the left, the blackfish, I have 1, 2 of them. So again, I'm going to put a 2 first. The redfish, I have 1, 2, 3. So I'm going to have 2 to 3, or 2 to 3 written in fraction form. Notice that my total number of things, so if I add up the 2 and the 3 here, I get 5, which is the total number of fish. So my total number should be shown in the combination of each of the things in my ratio. Now if I look at the second fish tank on the right, if I'm doing blackfish first, I'm going to count 1, 2, 3, 4. So I have 4 blackfish, and I have 1, 2, 3, 4, 5, 6 redfish. So my ratio is 4 to 6. When I write that in fraction form, what I immediately notice is that there's a common factor to each of those. If I divide the top by 2 and the bottom by 2, I get 2 to 3 as my ratio. And notice how that matches up with my answer over here. Both of these fish tanks, although they have different numbers of fish, have an equal ratio of fish. Here, for every 2 blackfish we have, we're going to find 3 redfish. Here, the same thing happens. I'm going to circle a combination of 2 blackfish and 3 redfish. The other thing that I'm going to circle has that exact same ratio. For 2 blackfish, there are 3 redfish. At this point, you should hopefully be feeling confident enough with this material to go ahead and try the example with the circles on your own. If not, listen carefully as I go through this example with you. For letter A, it says, what is the ratio of yellow circles to red circles? Well, I know that my number of yellow circles should come first. So I had 1, 2. So I'm first going to have the number 2. And then I'm going to have red circles, which is 1, 2, 3, 4, 5. So 2 to 5. Notice I'm only not writing it in fraction form because I don't have a lot of room here. Again, you have the option of any of the 3 methods. For letter B, we have what is the ratio of red circles to purple circles. Well, I already counted the red circles, and there's 5 of them. My purple circles, I have 1, 2, 3, 4. So my ratio is 5 to 4. Notice it is possible, if I wrote this in fraction form, the 5 would go on the top, the 4, the second number, would go on the bottom. I can have an improper fraction here. Important that I need to keep that in improper fraction form. The reason is, a ratio, remember, shows the relationship between 2 numbers. If I make this into a mixed number, I would have 1 and 1/4. Notice I now have 3 numbers, so that's no longer a ratio. My ratio should just have 2. For letter C, it tells me the ratio of purple circles to yellow circles. Well, I had 4 purple circles, I'm just going to draw an arrow, and I had 2 yellow circles, so 4 to 2. Again, even though if I reduce this, I have 2 to 1 as my ratio. If I divide the numerator and denominator both by 2, I know that it's true to say that that equals 2. I'm not going to put it in that form, though, because I need to have 2 numbers to show a ratio, the ratio of 2 to 1 there. Letter D says the ratio of yellow circles to purple circles. Well, I have 2 yellow circles, and I have 4 purple circles. Again, I need to make sure I reduce. My final ratio would be 1 to 2, since 2 and 4 both are divisible by 2. Go ahead and look at identifying each of the following ratios related to the different shapes here on your own. I do want to go over, because the goal of our lesson is not shapes, but to look at ratios and make sure everyone knows what each of these shapes are. Triangle should be pretty obvious to most of us. Rectangle as well should. The other shape that we have, though, is this shape here, and it is called a trapezoid. Trapezoid. I ran out of room there, but it should be one word. We'll go over this tomorrow in class together.